Okay, good morning, beta. Good morning, Vishal. Good morning, Darshini. Good morning, Kaushika Shri. Good morning, Sharmila. Good morning, Ekta. Good morning, Darshini. Darshini still eating chocolate. Good morning, Darshini. Good afternoon. It's not okay. Good afternoon, beta. Good afternoon, Jiva. So what we are going to do is I am back, Keshav. Okay, welcome back, Keshav. Monish, good morning. Sorry, Krisha, good morning. So till now we have understood all the tough section of chemistry. Now it is the most easiest section. Exactly. What is evaporation? Of a liquid into its vapor state I am checking some children have joined now, but I am unable to take your name because I am very much here in this question. So evaporation part I am writing Keshav, through which water converts into vapor with heat energy. This is what I need to explain here, beta. So okay, teach with chocolate. 100% I will teach with chocolate, but I am just waiting some more children to join. Okay, fine. Now look here, beta. The phenomenon of change of, so what is exactly evaporation means here? Is this definition is going to let us understand evaporation, or we are going to understand evaporation in our own way? So definitely, beta, the phenomenon of change of a liquid into its vapor form means it is exactly a process where liquid will get converted into vapor at any temperature below its boiling point. Then it is definitely a unique thing, because now if we will go back to the flashback, we just have a flashback, we will go in the previous class where we have understood that vapor formation of water is exactly done when we have provided heat. But here exactly, and then the thermometer was showing 100 degrees Celsius, and after that, beta, what has been done here is, and after that it was started getting converted into vapor. Now I want everyone to join and learn it very nicely. This is a very important section. I have to explain many important points here, that I only request my children to focus to some of my points which is very important right now. So please children, listen to me very nicely, and I am going to explain both the difference. Okay, now first what we have studied in the previous class, and then what we are going to study here according to the definition of evaporation. Both difference I am going to show, and then I am going to let you judge which one is exactly you have understood or not. So in the first case, what we did, we exactly took a tripod stand, wire gauge we took, and we started exactly heating. With the help of Bunsen burner, we started heating a beaker which is exactly having water, and in that we have fit one thermometer with bulb is there, and it is constantly inside. With a stand we just holded this one. Now in this thermometer we saw that this exactly, the thermometer attended exactly 100 degrees Celsius. Okay, 100 degrees Celsius, it has attended 100 degrees Celsius or 373 Kelvin. And after this the thermometer temperature did not change, and the water started coming out, started coming out in the form of vapor. Okay, then we understood that boiling point is 100 degrees Celsius or 373 Kelvin. This was the previous concept we have understood. Okay, here also that means what, it is a case of vaporization. Then also I told you that beta, these water molecule have gained a hidden energy, the energy given by the heat, this they have exactly absorbed it, that is called as latent heat of vaporization. So this latent heat of vaporization was received by the particle, and then this particle overcome the force of attraction. For some time I really want today, Bunsen burner, what is under the table? What is there under the table? Under the table nahi beta, on the table beta I have exactly kept a Bunsen burner. My drawing is like this only, children. It is not a table, it's a tripod, and exactly here one Bunsen burner having flames. Imagine, for understanding Khushbu auntie's drawing na, somewhat you have to imagine also because I can't draw nicely. So definitely beta, I'm just definitely Bunsen burner is there. From that flame will come out na beta, that is what. Now listen to me very nicely, children. Understand this. Then how this section is different from evaporation. How this section is different from evaporation. Now I have kept a bowl full of water. I have kept a bowl full of water, and exactly I filled the water from till the top level. Okay, now sun rays, and I kept it outside. Okay, now sun rays are falling in this. Only one thing is that the sun rays are falling in this, and after 2, 3 hours, 4 hours I returned back and I saw that the level of water got down. Okay, understood or not? Second, I kept a bowl outside, and today it is not a sunny day. It is not a sunny day. I kept the bowl. Oh, drawing is super. I want you to understand both the difference nicely, and that's why beta I am discussing all this. Again I filled the bowl fully. I'm keeping it for the birds who is coming, but no birds are coming, and today it is exactly it is not a sunny, it is not very hot day, it's normal day. So after 2-3 hours I came again, I saw in absence of heat also some water got evaporated. Correct, Keshav. Darshini. She's telling spirit lamp. Darshini, beta, very seriously I am teaching something. Bunsen burner. What is Bunsen burner? Beta, it's exactly type of burner which will come out, which will take out heat, beta. Okay. Experiments, Bunsen burner, exactly there in the drawing. I will send you that pictures. In group you will be getting it, don't worry about it. Now beta, listen to me very nicely. I am talking about evaporation right now. This was an experiment we have done to understand how water is getting converted into vapor, and there was some heat energy taken by the particles and then leaving the surface. Okay, then you will say that ma'am, here we are going to talk about evaporation, but here we have not at all provided any heat. Okay, here did we use Bunsen burner? No. Here did we use only sun rays are coming and sunlight energy is there, and atmospheric whatever heat is there, that is present and natural. If means if sun is also not there, then too some small amount of evaporation will be done. That means evaporation is, listen to me very nicely, evaporation do not require heat also. How can this be possible? Let us understand this first. Okay, so I am giving some conditions in front of you. I want everyone to listen to me nicely. If you will play right now, you will not understand this. So beta, what I am advising you, I am just giving you a possibility right now. We will come out with all the answers, but first understanding is needed now. So what we have seen here is no Bunsen burner. Now observations. Observation is very important. Like me and Darshini, we both have kept the bowl outside, and we are seeing that from my bowl also water went, and from Darshini's bowl also water went. Now I have kept in direct contact with sun. Darshini has kept it indirectly. She kept it on floor in her balcony where sun rays are not falling directly, but she kept that bowl in her balcony. And after some time she called me and said, "Auntie, from my bowl also some water went out, auntie, it got evaporated." Then I will also see in my balcony and say, "Darshini, from my bowl also water came out." Then Darshini will ask a question, "Ma'am, I have not heated the bowl, then how water came out, auntie?" Understood not? So this was the question asked by Darshini. I kept under sun, so evaporation is normal. But she has kept in balcony where sun rays were not falling directly, but slowly evaporation was going on after that also. After not giving this in direct contact with sun rays, then to evaporation happened. Then Darshini got fully confused. She called all the friends and came to me and asked that, "Ma'am, how can this be possible? How can this be possible? If we are heating and converting into vapor is a normal one. Every day we are seeing this. When my mother is cooking food, water from that is exactly when she is heating water, water is coming out in vapor, and that one we are seeing. But here, without supplying heat, how can evaporation done? How can evaporation be done?" That is what I am going to clear each and every doubt of my children. Just you have to listen to me patiently, and then you have to, because I will make you as if you will itself answer my questions. Okay. So Darshini told, "Ma'am, you have given this definition. This definition, ma'am has given that phenomenon of change of a liquid into vapor state at any temperature." That means not of specific 100 degrees Celsius. At any temperature below boiling point. What is the boiling point of water, beta? Boiling point of water is 100 degrees Celsius. And once we will keep on continuously boiling it, then the water will come out, 100 degrees Celsius will be maintained, and water will come out in the form of vapor. So boiling point is 100, and specific temperature you have given by use of Bunsen burner, by use of flame, you have given specific temperature, and that temperature was gained by the particle, and these particle gained this temperature and come out in the form of vapor. Okay, once the water attained 100 degrees Celsius, this particle started gaining that heat, hidden energy, and then it came out. This already we have discussed. Then here there is no Bunsen burner, no heat given, no temperature changing. Without change in temperature, without giving heat, how evaporation done? But two important points in the definition of evaporation is that this is the most important point you have to remember, that is conversion of liquid into vapor below its boiling point. Boiling point of water in the previous section we have seen 100 degrees Celsius, but evaporation here done below its boiling point. Below its boiling point. And next important point to focus here is at any temperature. So these two are most important point to remember in evaporation, that evaporation is done below the boiling point of water. Second, at any temperature. Here we have not provided any external heat in the system. Second, we have not increased the temperature. It is not like now we are boiling the bowl. No, we are not providing any heat from the system. Rather than that, this bowl is receiving heat from the surrounding beta. This bowl is receiving heat from the surrounding, whatever is the temperature of the surrounding, and it is receiving heat from sun and from surrounding. This bowl is not even receiving heat from sun, it is receiving only heat from the surrounding. Means what is your room temperature? At that room temperature, that is what na beta many a times you have seen. Below boiling point at any temperature. Evaporation, two key points. Below boiling point at any temperature. I want my children to understand this nicely. Key points to remember for evaporation. Below boiling point at any temperature. Below boiling point at any temperature. No heat given. No specific temperature maintained. No specific temperature for evaporation maintained. Then suddenly Rahul will come and say, "Ma'am, now I understood, ma'am. Yesterday you know what happened. Inside my home also evaporation happened, ma'am. What happened? I was I was drinking water, and suddenly some drops of water fell in the ground. So I forgot to wipe that. After 15-20 minutes I returned, ma'am, that drops were not there. I thought my mother will scold me that water is there, anyone can slip and fall on the tile. If water will be there, then anyone can slip and fall. I immediately came to wipe it. When I went inside, I saw no water there. Then you will be saying, yes ma'am, every day we are saying that when we are mopping the floor, now water will be there in the floor. After some time this water is disappearing, ma'am. Where is this water going, ma'am? Inside restroom also, ma'am, where there is no heat, when we are taking bath, the tile will be full of water. But when we are not going to restroom for 5 to 6 hours, after that immediately if we are going inside, we are seeing the total tile is dry. There too we have not given any heat. Then where this water went? Where this water went? Did you heated the toilet? Did you heated the floor? No. But where this water is going? Where this water is going? Now the correct answer is exactly, I hope my children are now understanding. Every day, beta, every day this is happening. It's not a new thing. Every day this is happening. Every day this is happening, that when you are exactly providing heat, means when you are not providing heat, the room at room temperature itself, tell me yes or no, are you experiencing it? Vishal, here we are talking on, yes. Correct only, Merunisha. Correct only. Vishal, evaporation is not dependent on perfect temperature. Then you think about, beta, your room having 100 degrees Celsius. Think about it. Right now you are inside a room and your AC will be on or something will be exactly, fan will be running. Then too, beta, it will not be at 100 degrees Celsius. Room temperature 100 degrees Celsius means what will happen? We will become fried chickens only. Sorry, it came sarcastically. It is not 100 degrees Celsius will never be there, Vishal. For evaporation below boiling point. Evaporation, two important points, beta. Yes, we will definitely get, we will not be able to breathe even, Vishal. You know what will happen? We will start feeling that heat and our perspiration rate will become very high. So evaporation will be done below boiling point, below 100 degrees Celsius. Much below, and it is not at all needing. So Vishal came and said, ma'am, I'm having one confusion, ma'am, I have exactly kept my dress, water fell in my dress. So what I did is I hanged my dress on that wire is there na, and I kept it for some time. My dress dried and then I wore it again. My shirt was exactly wet. I wore another set and I hung that shirt, and then after a few hours that shirt got dry. How that? I have not boiled that shirt, I have not given heat to that shirt. Then how that shirt water went? Where it went? Where it went, ma'am? So definitely, Vishal, did you give 100 degrees Celsius to your shirt? No. Outside room temperature is what, beta? General room temperature, outside temperature is maximum, you know, summer vacation, the temperature will reach maximum 37, 36, 40, maximum. Some region only where it is attending 41, 42, their people are not coming out of house. You know why? Because they will get dehydrated. From their body, water will start coming out in the form of vapor. And beta, when you are heating, you are giving 100 degree, then water is coming out. So that means evaporation. These examples are telling us one very, because of temperature, correct only. Because of temperature, and because of this, beta, we have learned a very important thing, that evaporation is done much below the boiling point. Much below the boiling point, and evaporation can be done at any temperature. Evaporation can be done at any temperature. Evaporation can be done at any temperature, beta. Evaporation can be done at any temperature. So these are two important points which I want my children to understand. Now I am going to start my story how evaporation is done at any temperature without taking heat from system. So here system is there, Bunsen burner is providing heat. So without taking this heat, how can evaporation be possible? This we are going to understand now. So what we have done is, yes, sunlight somewhat, but beta, you itself tell, you are inside home and your fan is on, only, and you are mopping the floor, water is there in the floor. After some time that water is going without sun contact, means without sun contact, the water present in the floor will get dried. There to sunlight is not there na. Then 100 degrees Celsius will never be possible inside room, because we human are also present there. We will become roasted if that much temperature will be attended inside our room. So think about it. I want all of you to think today. Really, I want my children to give me the best answer. Vishal, Rahul, Vineet, everyone, Keshav, girls, Darshini, Divyashri, everyone, Merunisa, Ekta, Kritika, everyone, think about it. Because beta, chemistry answer will be in your thinking only. That every day you are seeing this, every day, but never you thought of evaporation inside room. So now today I want you to think. So exactly how evaporation is done at any temperature, not a specific temperature, any temperature. Means if I will go to my native also, there also if I will put water on the floor, after some time exactly the water will be vanished. It will come in the form of vapor. So whenever I want to dry my cloth after washing, I am hanging the cloth, and then after some time the cloth, wherever I will go for drying, I have to hang the cloth, and from atmosphere the water vapor will go somewhere and the cloth will become dry. So these are certain normal things we are seeing every day in our day-to-day life. But what is exactly happening there? So when you have kept a bowl, now beta, inside this bowl, water is there. Now beta, understand it in a very easy way, that these bowls, now these bowls are having water molecules. Now understand, this is the particle, liquid particle, this is again liquid particle, water molecules we can say. Now these are liquid particles, okay, water particles you can say. Now what is happening between, see, but what this is exactly, the bowl is exactly full of water right now. Now beta, these particles will be exactly present inside. Now these particles will experience two things beta. Already again and again I am telling. One is, listen to me very nicely. In this bowl, if it is full of water, then beta, from top, air pressure. So what one thing you are experiencing here is air pressure. The surface of the water, whatever particles are present in water, they will first experience air pressure. Because beta, everywhere you will be having that 1 atm atmospheric temperature pressure is there na, above the sea level. I have discussed last class that air will definitely, air pressure will be there in general. 1 atm air pressure will be there. So same, this bowl will also experience air pressure. Means these particles, imagine these particles present on the surface of water, they are experiencing this air pressure. Now this air pressure, it is telling these particles you cannot convert it into vapor. So this pressure giving stops the evaporation, means it is not allowing the particles to become gas. Okay, so this air pressure, so air pressure will be there. But one more important thing, if this will be hot air, now if temperature of this air means a very hot day, these air pressure will start giving energy in the upper surface. Okay, like in normal way, but this air pressure means inside your room air is there na. You keep a bowl, in that water you keep, then you keep your hand above the bowl and take it near the fan. You will feel that fan is putting wind on the bowl. So definitely air pressure will be there on the upper surface of the water. So definitely these air pressure will try to what you call put pressure on the surface, and it is exactly going to create a surface area. This in this surface area it is going to create some pressure. So this is air pressure. From surrounding, air pressure will be there. I am unable to read. Correct only beta. Correct only. Awesome. I am unable to read your statement right now because I have to explain this point. Next important and very very important point is between two particles. Force of attraction between these two particles. We already know na beta. Liquid force of attraction is there between these two particles. That is exactly attractive force. So that is what force of attraction is there. So these two particles are exactly holded together by some force. Okay, then what will happen? What will happen to the system? These particles, that is exactly interparticle force of attraction. So these two particles are there. They are having interparticle force of attraction. Each and every particles are having interparticle force of attraction. They will be experiencing interparticle force of attraction. That's why I am drawing like this beta. Means each particle will experience interparticle force of attraction. You see here one particle is at the center and it is experiencing interparticle force of attraction from all the sides beta. From all the sides. Can you see this particle experiencing interparticle force of attraction or intermolecular force of attraction from all the sides? So like this all the particles will be exactly binding each other, and that's why they will be only in the liquid state. They will be only. So these two factors will allow them to be in the liquid state only. First is the air pressure. Second is the interparticle force of attraction. So what they will do is they will allow the particle to be in that state. They don't want the particle to get converted into these molecules to get converted into vapor state. They always want them to in which state? They always want them to be in the liquid state only. Then you will ask, ma'am, you are telling, auntie, you are telling that these two are exactly opposing them to get converted into vapor. Then how they will get converted into vapor, ma'am? That means they will always be in liquid. Then there will be no evaporation. Then there will be no evaporation because this intermolecular force are binding them together. And then ma'am, air pressure also is exactly not allowing them to come out from the surface in the form of vapor. Then so these two will always oppose and the liquid will always be liquid. It will not come out in the vapor form in absence of heat. Then I will tell you that one very important part is there. That part you must understand. No problem, I am not, beta, I am unable to read your statements now. First understand this part, beta. I am not able to read your statement. I am ready, I am exactly in very much here to explain the point today. Okay. So now then what will happen here, beta? Then what will happen here? Then evaporation will start. Now under this, now look here, beta. You have to understand one very simple phenomena here. Okay, so phenomena is very very simple. I want my children to understand. These particles na beta, inside the liquid, they are always in random motion, continuous motion. Means liquid particles are never in one place. They keep on moving inside the liquid. They are experiencing intermolecular force, but they will be moving inside the liquid. They will not be at one place. Like solid, all the particles will stick to one place only na. In liquid, the liquid particles will be present inside liquid, but it will be in random motion. It will keep on moving. Now when the particles will be exactly moving inside the liquid beta, they will experience collision. Collision means what? At the time, like these three particles are there. So what they will do, this particle will go, because all are in random motion, this particle will go and collide with this. After hitting this one, it will come and hit this one. After hitting, its direction changed. It again went and collided with another one. Then this one, this A, kept on colliding with other. So it collided with B. After collision, its direction changed. Then it collided with C, then after collision its direction went, and then it collided with D and it came to different direction. So this is exactly, Darshini, I will clear your doubt beta. Tell me. Tell me what doubt you are having. But you understand this point beta, that they will continuously collide, they will hit, go, collide. So this collision is complete elastic collision. Elastic collision means what beta? Elastic collision means, elastic collision, this type of collision is complete elastic collision beta. That means what beta? In this beta, each particle, like I am there, you all are there, we are exactly colliding, but what happened here is this particle is having kinetic energy. Now it went here, it hit this one, then it gained some energy from this one, it gained some energy after collision from this one. So every time when the particle is exactly colliding, it will keep on gaining some energy. Okay, so here collision is completely elastic, but here beta, at the time of collision, the particle gives its energy to the other one. So one state will come when the particle who is exactly moving inside the system will keep on gaining energy. So one state will come when this particle will gain energy more than the energy of this system, and it will come out as vapor. Okay, that means what I told you, that means they are always in continuous motion, the particles are always in continuous motion. Now what they will collide with one particle, change in direction, then another particle, then another particle. In this, during collision beta, what they will do is they will exactly collide and gain energy. So this energy, the particle will keep on storing it due to collision. Okay, due to collision, this particle will keep on exactly, this type of collision is completely elastic beta. This type of collision is completely elastic, and beta, what will happen, account of collision, this particle will keep on gaining more energy, and one state will come, this particle will have more energy than this surface energy, and then this particle will come out as vapor. So that's why beta, these particles are not requiring heat, but this definitely evaporation is a slow process beta. Like what experiment we have done, in that we were giving heat, but here heat is exactly taken from the surrounding. Like if room is very much hot, that day evaporation will increase beta. Why? Because this air which is putting pressure on the surface, this is hot air. This is hot air putting pressure on the surface. So when hot air will put pressure on the surface, it will give some energy. It will give some energy to this surface particles. So these surface particles will gain that energy beta, and then after collision also it will be gaining the energy. So you have to understand that the more the particle is active, the more the particle is colliding with other particles and gaining energy, that particle chances of coming out as vapor will be more. And evaporation is a surface phenomena, means these particles which is exactly present on the surface, they will be getting energy from outside also. That means that heat energy from outside, from the room also. So imagine Kishore has kept room temperature of, one boy is there, Kishore, he has switched on his AC and his room temperature is 16 degree, and Khushbu auntie has exactly kept her room without AC and her room temperature is 24 degree. Can you tell me whose room evaporation will be more, Kishore's room or Khushbu auntie's room? In whose room evaporation will be more? If tea is hot beta, at that time you know what, understand there is always a temperature difference. Yes, in my room evaporation will be more. Why? Because beta outside heat is more, and that's why evaporation rate will increase. Darshini, your question is very good beta. Darshini is asking a question that, ma'am, if I am keeping a cup of tea and in that outside room temperature, it's exactly outside also heat is there and cup is also hot, then the cup should be exactly hot for a long time, but the cup is getting cooled. The answer here is, Darshini, the answer is very simple, Darshini. You think about it beta, this temperature, the temperature of cup is higher than outside temperature. So this temperature is T1, cup inside temperature is T2. Right now heat inside the system is more and heat outside the system is less. And if you will blow air, like some people now, when they are drinking tea now, you will see they have a habit of doing like this, like this they will do. Why they are doing this? So that beta the surface, or what they are doing is they are exactly keeping that, if they want, they are in hurry burry, you might be seeing that in the plate they will put the tea and then they will drink it, and they are drinking fast, but in cup they will not be able to sip it more fast. The reason is surface area. Now listen beta, now inside the system temperature is high, outside temperature is low, then heat will start coming out from the system outside. When inside is high heat and outside is low heat, then heat will start coming out from the system, and it will come out until and unless both outside and inside temperature becomes constant. That's why Darshini, when you are blowing air, the heat is exactly coming out from the system fast, and that's why beta teas are getting cooled when you are keeping in front of fan. The reason behind is now radiation of heat become faster and the heat will come out in fast rate. Yes beta, this is what, very good Vishal, very good Keshav. I hope my children might have understood. Yes, correct only Lokesh, absolutely correct. Darshini, now you understood now. That means what beta, now you have understood when your mother is giving you a glass of milk and that is very very hot, then you are keeping the milk for some time, and when your mother is asking why you are not drinking, you will say amma pal is sudirk means heat na ma'am, amma means mammai, milk is exactly hot, and then you will keep it for some time, then it will become cool and then you are drinking. Then what, where is the heat going? In the system or outside the system? Inside right now the milk, inside the particles, that milk particles are exactly, these molecules are having more energy. So what it will do, in the surface they will release this energy, and that's why beta it will become cool after some time. I hope my children might have understood. Understood or not? Tell me first. Understood or not? Learned anything? That means beta most important point is evaporation is not at all need the heat from the system. It is exactly done below boiling point. Here you exactly below boiling point only evaporation is done. One more time I am explaining what happened. They are not wanting liquid molecules to come out in vapor form, but these molecules are keep on fighting with each other, and the more they will fight, the more they will gain energy, and one time will come when they will be exactly having energy more than the system and it will come out as vapor. So it is due to internal collision only beta, they keep on gaining the energy, and then that's why beta evaporation is a slow process, boiling water is a fast process. Evaporation will not be done. That's why I told you na beta, we kept the bowl under sun for 4-5 hours and then only some amount of water got evaporated. Okay, all, not all. I hope my children might have understood that. That means what, the slowly and steadily the particles will gain energy by colliding, and from the system outside, from the system also the particle will gain energy from outside system, means from air, from surrounding, from the container, and then the particle will gain extra energy and then they will try to come out from the surface. So evaporation, that's why beta your clothes, when you are exactly giving the clothes for drying, it is not dried within 5 minutes. No, na. It is taking time. You are exactly hanging the cloth for 4-5 hours, 10 hours according to the texture of the cloth, and then the cloth is getting dried. I hope you might have understood. Understood or not? I hope my children might have understood. Quickly give me a nod. Yes ma'am, understood. Yes ma'am. I want my children to say yes ma'am, understood. Okay, super. Super. I hope Vinith understood, Lokesh understood, Monish, Krisha understood, Vishal understood, Ekta understood, Lokesh, Sharmila understood, Darshini understood. Now what chocolate you have kept, now give it to me. I am going to eat. Vinith understood, Ekta understood. I need that chocolate. I am very tired. Now you can eat that chocolate beta. Now listen to me. I am going to keep it till here. Enjoy homework. Submit files nicely. Rahul understood na beta? Fine. I am going to keep it till here. Merunisa understood na? Ekta understood? Ekta, what happened? You didn't understood? Thank you, beta. Understood, na? Chapter completed. No, chapter is not completed. Factor effective evaporation is still left. Our some part of the story is still left, beta. After that. Okay, I'm going to keep it till here.